So now again, welcome. Uh, in last lecture we were discussing about the energy audit. So highlights of the last lecture was the highlights of the last lecture is what is the need of energy audit, what are the objectives of energy audit, and what is the classification. The classification definitely it is based on some method. It is also depend upon the client financial readiness to invest in the energy audit. Again, it is also depend upon the type of industry or type of client or type of say any organization where we want to do the energy audit. Okay, so now we will proceed further. So in type of energy audit, we were discussing about the preliminary energy audit. We discussed some about the preliminary energy audit. And last point which we have discussed that in the detail energy audit, that is in the detail energy audit, in the first phase is the pre-audit phase, second is the audit phase, and third is the post-audit phase. And in the pre-audit phase, what is the points have we have discussed? That is the discuss economic guideline associated with the recommendation of the audit. That is either the client is ready to do the investment, fresh investment in the replacement options whichever be given by the energy audit team. Analyze the major energy consumption data with the relevant personals, because in each and every section of industry, or say in the process industry, some utility section, some material handling sections are there, production sections are there. We have to make some small meetings with these people, so that we are able to understand what is the major energy component, what is the major energy consumption devices or machineries are there. Obtain the site drawing whichever be available. The objective of the site drawing is that the energy auditor can understand what is the distribution of steam line, what is the distribution of hot water, cold water, cooling system, electrical distribution system, so that if by a small modification in the pipeline, definitely we can save the energy, we can improve the efficiency of the pumps, because by doing such activity we can decrease the static head, we can decrease the leakages in the systems, isn't it? So therefore the distribution layout is very much necessary for proceeding the in doing the energy audit program. Now tour with the site by including some site engineer or say factory manager. The objectives of tours is the objectives of tours are that is to finalize the audit team. Definitely we have to make the audit team uh, people or representative from the auditor side and representative from the client side, because it is the mutual effort of the auditor as well as the workers or the people those are working in the factory. Then and then it is possible to do the energy conservation or energy audit program, and it is giving some fruitful result. Otherwise, if you're not making the confidence among the people, definitely we cannot do the we cannot say execute that program. To identify the main energy consumption area plant item to be surveyed during the audit. So the second objective of the tour visit is to identify the main consumption area. Where is the main consumption? Either in the utility, either in the compressor, it is the boilers, or say cold water system, some cooling towers are there. So you have to identify which is the most likely area, or where we can do the more energy saving. So if definitely if the machines are consuming more power, definitely its capacity is very high. And when the capacity is very high, we have to conduct some practical, we have to take some readings, actual reading, instantaneous power, you have to take some records over the month or over the some shifts, so that to understand the need of that instrument and to identify the or to come with some conclusion for the fruitful result in the energy conservation. Second, to identify any existing instrumentations or additional meters are required. Either whatever the meters, whatever the indicating type of meters or recording type of measuring instruments are sufficient, or we have to add some additional measuring instrument for energy audit. So in this case, we have to identify what are the new meters has to be installed, because in existing system some indicating type of instruments are there. Say there's a temperature indicator, is maybe a voltmeter, a meters, or it may be a watt meters even, but that watt meter is connected entirely to that particular section of the industry. It may be a utility side, it may be a production side, it may be a material handling side. But if you want to do the analysis over a single machine, then you have to connect one more meter, or you have to keep some portable meter so that we can measure the detail parameter of electrical side at either it may be a thermal side for the particular. So therefore either the instruments which is connected in the system is sufficient or any additional instruments are needed. So it is also going to identified, it is also going to say decided in the tour visit to decide whether any meters will have to be installed. Okay, the same things. Now it is not only the electrical measuring instrument, it may be a some pressure gauge, it may be a temperature, it may be a some sensors are there to be installed to identify the instrumentation required for carried out the audit. Definitely we have to bring some more other instruments are there, because say for example leakage detector. In industries continuous sounds are there. Suppose for example anywhere if there is some leakage we will heard some hissing sound, but in the industry or but in the some production unit or some factory, continuous different type of sounds are there, isn't it? So we cannot examine only by hearing there is a leakage. So you have to use some leakage detector. The water leakage can be carried out, water leakage, steam leakage, because it is somewhat visible, isn't it? But compressed air we cannot identify because there is no smell also, there is no some visual uh, things are there in the. So such type of leakage detectors are to be used to identify the leakages in the pipelines. It is found that only by trapping the leakages, either that is a wastage. So only by trapping or reducing the leakages in the pipeline, leakages in the other system, definitely we can serve or we can do the energy conservation program. Now to plan with the time frame, definitely we have to check out the activities, which type of activities to be carried out first. So it is a frame, it is a roadmap to be prepared for carry out the energy audit, to collect the micro data on the plant energy resources, major energy consumption centers, isn't it? So you have to make some charts as per the section of the industry, and we have to collect the micro data to create awareness through the meetings. Definitely we have to aware the people, we have to educate the people what is the importance, what is the advantages as a industry, as a individual, as a environment, what is the advantage of energy conservation. And uh, if they are come into the confidence, then and then it is possible to do the energy audit program. Okay, now second phase is the detail energy audit. So in the detail energy audit, there is a three phase are there, three components are there: preliminary energy audit, detail. Second is the detail energy audit. In detail energy audit, phase one is the pre-audit phase, which we have already discussed. Second is the detail energy audit, and third is the post-audit. Okay. So second phase, energy consumption by type of energy, by department, by major item of process equipment by the end user. Means you have to make the chart. First of all, the first classification is that by the type of energy. Say electrical energy is different, thermal energy is different. So you have to make the different atom wise in the thermal energy. What is the cooling tower temperature? Okay, what is the temperature of furnace? What is the recommendation is there? What is the temperature to be keep in the cooling towers? What is the pressure? What is the steam level? What is the steam temperatures? So all these parameters comes into the thermal energy. So I will give my example, which we have conducted the energy audit in Hindustan Lever Limited. Now it is a Unilever one in the Khamgaon factory. It is a soap factory. So during that time, it is found that as per the recommendation, the temperature to be kept at 15 degree water temperature. Let's say cooling tower, cooling water is there. So it is a 15 degree, for example, but they are using temperature of 10 degree. So it is not needed 10 degree. So if you use below that required value, definitely your compressor will remain on. It will consume more power. So therefore, we have to compare with the standard or the recommendation or as per the manual or guideline given by the different process. In that process, the temperature is needed 15 degree, but they are keeping as a 10 degree. So continuous losses are there to decrease the temperature from 15 degree to the 10 degree, whereas the requirement is only the 15. So therefore, it is necessary to understand the layout as well as the recommendation values for the different applications. What is the temperature needed? What is the hot water? What is the compressed air is needed? If you are using more than that value, definitely there is a losses. So in the detailed energy audit, we have to separate the electrical energy as well as the thermal energy. So this is the one by department wise, because there are different department, different section, utility section, then production section, then material handling. It is some raw material processes there. Okay, so different area has a different energy consumption detail. Now, this is the second category of preparing the data, and third category by the equipment. For example, in some process there are 20 pumps are there. So we have to make the chart. 10 HP pump is there, 20 HP pump is there, 50 HP pumps are there. So this is the chart which we have made equipment wise, department wise, and energy wise. So we have to prepare this activity, and we have to decide which type of data to be collected for 50 HP motors and 10 HP motors. Okay. So 50 HP motors, we want to examine the power factor also. If individual power factor of motor is small, you have to improve. You have to check the loading of the motor, which we are going to understand one by one. So just I am giving the example which is related to the type of equipments. Material balance data, that is raw material, intermediate, and final product. Recycled materials, use of scrap and wastage is there. It means that if you are purchasing the raw material of 10 ton, how much either you are producing the 10 ton or less than 10 tons is the final product. If there is a large gap between the raw material and finished good, it means that there is a wastage. So which kind of wastage is there? Either it is recycled, then it is okay. But what would be the percentage of recycling? If your percentage of recycling is very high, definitely it means that there is some negligency in the process of production. So you have to identify which is the negligency. If you are able to rectify that process, if you are able to rectify this negligency, definitely we can improve the quantity of the finished product. So this is one, it is a waste. Either it is a recycle. Second, it is a scrap, it become a scrap. So if it become a scrap, definitely the cost of scrap will not be a good, and you are purchasing at a higher rate and selling with a small rate. So this difference has to be minimized. So therefore, the material balance sheet is very important. If you are taking the fresh water, how much water is you are how much water you are taking from the supplier, from the corporation or from the MSD, MIDC office, and whatever it may be the supplier. Well, supplier things are there. How much water is utilized in the production itself, and how much water is going to waste. So if you are keeping the record, if you are keeping the account of the water input, water utilized, waste water, recycled water, and where that water is going to utilize, is going to this one. So if you have a such type of activity, definitely we can reduce our wastage. So this is implied for, this is applicable for the raw material, this is applicable for the energy input, this is applicable for the fuels as well as the waters. So this means the material balance, to understand this one. Energy cost and tariff data. So what is the energy cost? What are the different parameters included in the energy bill? It is the one is the kWh, that is the actual energy consumed by the consumer. What is the maximum demand? What is the different charges? What is the electricity duties? What is the taxes over the electricity one? And if if you examine all these parameters, you come to know that our maximum demand is very small, which is going to occur, whereas our contract demand is very high and hence we have to pay the more money as a one parameter. Or our maximum contract demand is smaller, whereas we are drawing more than our contract demand, then you have to pay the excess demand charges as well as the penalty. So if you understand the tariff, if you understand the electrical energy, or if you are able to understand the energy cost, then either you have to increase or you have to decrease the maximum demand. So these parameters are going to identified by keen analysis or proper analysis in the electric bills. Process and material flow diagram. You have to make some flow chart from where we are getting the material, the things which we have already explained in the second point of this section. Then if you are going to make some flow chart, what is the wastage, okay, which what is the different type of wastage, either this waste is going to recycle, either it will become a scrap, and what is the use of scrap is there. So if you analyze this one, definitely we come to understand where is our mistake, because the people those are working, or the workers or the technicians those are working in the industries, they are not bother about it, or they are not supposed to do that analysis. So the some external people, some external agency, energy auditor team is going to examine this one, and they will show that this is your input material, this is the cost of material, and this is the finished product. There is a difference between finished product and the raw material, and this much is the losses, this much is the wastage, this much is the recycled material, and this is because of these wrong practices. If you avoid these wrong practices, if you adopt some good practices, definitely we can decrease our waste. So therefore the material balance and process flow diagram is very much necessary. Okay. Now, next point is the generation and distribution of site service. What is the generation? It is not only the, if you have a own generating plant, if you have a only distribution. So what is the distribution methodology we have adopted? What are the different type of cables are there? What is the route of cable? Isn't it? Now, second is the compress. It is not only for the distribution of electrical, say energy. It is also the compressed air. It may be a steam. It may be a hot water. It may be a cool water. It may be a chilling plant. It may be a cooling towers are there. So these type of whatever the utilities are there, we have to understand the layout of utilities and distribution of the utilities. So definitely, if the pipelines are very long, it can be make some new routes, so which will avoid the number of bends, which will avoid the length of and height of the pipe. So it definitely it will improve the efficiency of the pumps are there if it is related to the pump. If it is a steam, so you can understand where the thermal losses are there, isn't it? Somewhere the insulation is going to deteriorate or some vanish over there because of the aging effect. So you can do the insulation, proper thermal insulations are there, and definitely it will increase the overall efficiency of the system. Next is the source of energy supply. What is the source of? Either you are taking from grid or you are generating on. So that is the electricity from the grid or self generation. If there is a self generation, we have to do the analysis of generating plant. If this is a grid, then you have to understand the tariff of the supplier or whatever the distribution agency is there. So which type of tariff it is applied for us, okay? And what are the way we can reduce the electricity bill? No doubt it is some ethical way. The meaning is that how we are able, can we reduce our maximum demand? Can we uh, say shift our less priority some process to the night time? That is, for example, if you have a effluent treatment plant. What is the effluent treatment plant? Whatever the waste water is there in the process industry, it is recycled or it is somewhat purified, and this purified water or some clean water is going to use in the garden purpose, in the landscaping purpose. So now it is not necessary to run this effluent treatment plant in the daytime. We can shift into the night time, because in the night time the electric tariff or the electric energy uh, unit rate is smaller. So you can shift into the night time. Similarly, the water pumping system, we can shift to the night time, isn't it? No doubt our process, our office, we cannot shift into night time. So whatever the less priority feeders are there, we can shift into the night time, and this can be understood by energy tariff or what kind of source of the supply are there. Now next is the potential for fuel substitution. Any potential or any scope is there to replace the existing fuel? For example, there is a boiler is there. Boiler is used for only generating steam. So you can replace coal fire boiler by the oil fired boiler is there, because in the coal fired boiler the control is very limited, control is there, isn't it? It required some time to ignite, as well as it is required some time to stop. So if you want some fast process or good control over the steam temperature and pressure, we can use the oil fired boilers. Okay. Similarly, if you want some hot water and you are using steam or you are using some boilers are there, we can replace it by the solar water heater system. If you install some solar water heater over the roof, definitely you can get the 50-degree, 30-degree is there. And so by this way, we can substitute the fuels. Here, the coal is substituted by the solar, and it is much more cheaper as compared to this one. It does not need some much more maintenance cost also. So this is the some potential toward the substitution of uh, fuels. Second, process modification. Can we do the process modification? For example, you have some one industry is there. So if you instead of purchasing the very raw material, you can purchase a second finished good material. Are you getting me? Suppose if you are have a oil industry, you are taking the seed. First you are extracting the oil, and you are refining that oil in your factory also. So what we can do, you can purchase the directly the oil, and by purchasing the oil you can process only, or you can do the refinery. So one step is just taken out. So this is the one modification in the process, okay? Or you can modify by some other means, whatever that available new technology is there, new method is there. Because of the aging effect, because of the old machineries, you can replace it. So we have to see the process modifications are there, okay? And the use of cogeneration, you can do the cogeneration. For example, um, you have some sugar industry. In the sugar industry, there is a number of sugar cane bagasse is there. After extracting the juice from the sugar cane, so whatever the waste is there, it is can be used for the generation of steam, isn't it? So some type of cogeneration, or it may be a combined some you have a grid supply, you can have a DG set, diesel generator set. In the peak time, you will start your generator and shift to the load to the generator side. so that your maximum demand will remain smaller. So this is called as a cogeneration system. It may be a combined heat and power generation. What is that combined generation heat is there? Say for example, you have some boiler, okay, boiler producing the steam at a higher temperature and higher pressure. But that higher temperature and higher pressure is not needed in the process. So what we can do? We can use this steam pressure for running a small turbine. No doubt that a small turbine is sufficient for the lighting purpose. It is maybe sufficient for some of the utilities are there, and whatever the say steam is available after use of turbine, it can be used in the process. So that type of say cogeneration or heat recovery system is there. We can adopt to increase the overall efficiency of the system. Okay, so this is the phase 2. Now energy management procedure and energy awareness training program within the establishment. You have to do some energy uh, awareness or energy conservation, some trainings to the peoples those are working over there, isn't it? Among the engineers, among the managers, or the some people those are working. Existing baseline information and report are useful to get the consumption pattern, production cost, productivity level in the term of the production per raw material input. So if you collect all this data, definitely we come to know that what is the input of the factory, what is the total energy consumption, what is the specific energy consumption, means uh, total energy consumption divided by the number of product. So that is give the specific energy production over there. So the audit team should collect the following baseline data. So they have to collect some baseline. What is the minimum requirement? What is the maximum requirement? So technology, process, use, and equipment detail. What is the technology they are using? Either we can do some upgradation of the technology. Suppose they are using the centrifugal pump. We can replace it by the submersible pump. So definitely the submersible pump will discharge more water, isn't it? And consumption will be small. I will give the example of our college hostel also. There is a 5 HP centrifugal pumps are there, and it is used to fill up the overhead tank in the hostel number 1. It required around 3 hours per day. Now we have replaced it because it is 2 or 3 times rewound. So instead of rewound again, has been replaced by the submersible pump of only 3 HP. So here the installed capacity has been reduced from 5 HP to the 3 HP, and the working time also reduced from 3 hours to 2 hours only. So this is by adopting the new technology. What is the technology they are adopting? Present, what is the present technology? Or we can replace it by the technological, or you can replace partial technological, so technological way. So that is a process. What is their process? Can we improve the process, methodology of process? Some by making some flow chart, we can improve the in process of the industry. Capacity utilization. What is the capacity and how much they are utilizing? If suppose the pump HP is 50 HP, but the requirement, actual requirement is only the 30 HP. So we are not using the total capacity. Okay. So therefore, this is the things are there which have to be understand the uh, capacity utilization. Next, amount and type of input material use, water consumption. What is the water consumption? Baseline, you have to identify. Fuel consumption. What is the fuel? Different type of fuel. Electricity energy consumption. What is the total energy consumptions are detailed. Steam consumption. Other inputs such as compressed air, cooled waters, etc. Quantity and type of waste generated, isn't it? So this is the baseline which we have to collect. What is the existing data are there? What is the electrical input? What is the mechanical, means the thermal input is there? Okay. How much material is going to converted into the finished product? That is balanced material, what raw material to the finished. What are other inputs such as the compressed air? What is the need of the compressed air? What is the requirement of the compressed air? Either they are producing more compressed, which is not needed. Then cooling waters. So what is the purpose of cooling waters? Cool water is there. What would be the recommended temperature is there? Okay. So in this case, we are going to collect the baseline of industry, baseline of the factory is there. Then percentage rejection. What is the percentage rejection is there? So if you reduce the reduction percentage, definitely overall efficiency will be high, will going to improve. The profit is going to improve, isn't it? The wastage is, so therefore it is very much necessary that to understand the balance material as well as the percentage rejection and reprocessing. So either whatever the rejection is there, it become a scrap or it can be recycled, it can be used in the as a, again raw material. So these are the points to be considered in the detailed energy audit. Data collection here. It is important to plant additional data is gathering carefully, whatever the data is needed. वो कौन सा which is that measurement system should be easy to use and provide information to the accurate as needed. Okay, and not the accuracy that is technically possible. So whatever that one, whatever the data is there, it should be a correct one. Measuring equipment can be expensive. Okay, so what we can do, instead of connecting the permanent instrument, we can use some portable instruments are there, isn't it? If suppose instead of using everywhere to install watt meter, we will use a one portable watt meter, and by this portable watt meter is there, we can measure the input of each and every machine. Suppose 50 motors are there, 50 pumps are there, or some 50 compressors are there, including all. We want to collect that data with the help of, instead of connecting the permanent meter, we can use some portable meters. So that portable meter will help to analyze very easily. Now, if the data is needed, recording data is needed, you have to explain to the people that you have to collect the data, you have to make logbook and the frequency of data. For example, if you want to see the temperature and pressure of cool water, steam is there. So you have to give some guideline to the workers or to the operators that I want that temperature and pressure level through or 24 hours with the frequency of 1 hour. Every 1 hour I have to want some data because I want to draw some graph, I want to do some analysis and what is the actual requirement and what is we are producing, what is the difference is there. So this is needed. Now the very important parameter in the data collection hint is that do not calculate when you can measure. It is very important. What is it means? We should rely on the measurement system. For example, if you want to calculate the power, power become P is equal to V into I into cos theta. I can calculate the power. But if the harmonic in the system, can we do the same formula? No. If there is some heat temperature is there and I am going to calculate the resistance loss at some different degree temperature, the resistance will be smaller and because of the temperature rise, the temperature of winding become higher one. So I cannot calculate the correct value. So the correct value is the measured value. So in the energy audit, we should um, rely or we should take as much actual reading as possible instead of calculating that from the standard formula. So this is the second one which we have here collected. The post audit phase. So next time we will continue with post audit phase. Today we have today we have discussed the pre audit phase, highlights of some pre audit phase, and detail of energy audit phase. So now I will stop here. Thank you.